talking about any sort of energetic process, we're usually talking about redox reactions. These are super important. Again, textbook definition of redox reactions are any reaction where there's an electron transfer between reactants. So we'll start by looking at an example of an electrochemical cell where we have a zinc anode and a copper cathode. So in this reaction, we would write it as copper sulfate, CuSO4, in an aqueous solution, reacting with solid zinc and converting into zinc sulfate and solid copper. So in this reaction, we can identify a couple of things that we've already seen before. First, this is a displacement reaction. So just like in precipitation reactions, if we're just given the starting materials here, we can predict what our products are going to be because we're just doing a displacement or metathesis reaction. Also, we've seen sulfate before. Sorry, my pen just decided to stop working. There we go. Okay, so we've also seen sulfate before, SO4 2 minus. Okay? So we know from our polyatomic ion chart that sulfate ion carries a -2 charge. So right off the bat, we can say, well, we know that zinc here has a 0 charge because it is just solid zinc, and copper also has a 0 charge of solid copper. This SO4, this whole species of SO4, has a -2 charge, which means our copper cation is going to have a +2 charge in this case. And the same thing over here in the products, our SO4 still has a -2 charge, our polyatomic anion, and our cation of zinc has a +2 charge. So again, we're looking at redox reactions when we're interested in the electron transfer between reactants. So we can say, well, look, what has happened with copper is it started with a +2 charge, and now it's going to a 0 charge. Okay, so plus to 0, that means the charge on copper has gotten more negative. In fact, copper in this case has gained electrons. So if copper's gained electrons, then zinc must have lost electrons, and we can analyze zinc. Let's do that in black, where we say zinc started with, well, we don't need a 8, size 8. Let's try this again. Okay, there we go. That's going to look better. We go from zinc, which started with a 0 charge and went to a +2 charge. So it became more positive. So our zinc has lost electrons. Okay, electrons are negatively charged. So in this reaction example, zinc has been oxidized. Which means it has lost electrons. And copper has been reduced. This slide kind of gives you a little mnemonic to remember these two terms that we just introduced. Oil rig, oxidation is loss and reduction is gain. So remember, reduction is gain of electrons, oxidation is loss of electrons. To confuse things a little bit more, we also have two more terms. One is oxidizing agent. So the oxidizing agent is the species that is oxidizing something else. Therefore, the oxidizing agent is the species that gets reduced in the reaction. And then likewise, we have a reducing agent. So this is the species that is reducing the other thing. Therefore, it's the species that gets oxidized in the reaction. So the reaction that we just saw, where we had a copper cathode and a zinc anode, these oxidation numbers, these values that we gave for the charges of copper, the sulfate ion, and zinc in the reaction, in the reactants, in the products, those were really easy to assign because we could say we have a polyatomic ion that we know the charge of, and this was probably one of the simplest examples we could come up with. It's going to be a lot more